myself Dr. Preeti Ragwani from Department of Computer Science, Arbit College, University of Delhi. So, in our present series, the topic which we are going through is about the packages, and in our previous class we have seen what actually a package is, what are the usage, and how the kind of access control fundamental works differently with the class and works for the class members, because a class is having only two access modifiers, one is default and another one is public, while a data member within the class can be public, private, protected, or it can have a default access. And we have also seen this table in our previous lecture, which is describing the control mechanism, or which is depicting the control mechanism for class members. So, in order to sum up this whole table in a short, we can say public member can be accessed from anywhere. Private can be seen or can be accessed only from within the class. If there is the default access modifier, that means no access modifier is mentioned, it is visible to all the subclasses as well as to other classes in the same package. That means we can say the default access modifier is package private, please understand this term, package private. And if it is kind of a protected member, then it is accessible in the same package and its subclasses present in any other package. So, protected is accessible within the same package, because within the same package except the private thing we have other things accessible, and also because it is protected, it is related to inheritance. So, it is also accessible in its subclasses present in any other package. Now, also we need to see the example of how this how the mechanism of packages is going to handle the name conflict. So, for example, we are going to take an example of two built-in packages. One is java.util and another one is java.sql. Both these packages have a class named as date. So, for example, if I am going to import both these packages as shown on the screen, that import java.util.start, that means all the classes of util package and all the classes of SQL package or sub package also, which says import java.sql.star. And if I am going to use the class date, so I have used the class date, and for this I have created an kind of a reference variable in the name of today. So, date today, this is going to give us an error. Why? Because which date we are talking about here, we have used util and we have used SQL also. So, whether we are talking about java.util.date or we are talking about java.sql.date, that is not clear to the compiler. So, therefore, date today is going to give us an error. So, now what is the solution? The solution says you need to qualify them with the complete package name. So, we will say in order to resolve this, we can say import java.util.date if we need date from util, and import java.sql.star. So, that means specific import statements is there to rescue us. This could be one of the idea. But if so here we have seen import java.util.date and import java.sql. So, when we say date today, it will refer to the util.date. But that is I have actually limited the program liberations here. What if both the dates are required? So, in that situation, if both the date classes are needed, then we need to use a full package name every time we are kind of referring to the date. So, for example, java.util.date, deadline is the reference variable, is equals to new java.util.date, the way we create the objects of the class. Similarly, for the SQL, java.sql.date is equal java.sql.date today is equals to new java.sql.date. So, basically here the reference variable deadline is referring or is pointing towards a particular object, which is the object of the class date belonging to the util subpackage of Java. And when we talk about the reference variable today, this reference variable today is actually pointing towards an object which is of the date class of the SQL subpackage of Java. Also with this we have seen how are we going to control the access mechanism using the concept of packages, how are we going to handle the naming conflicts using the concept of packages. One very small fundamental which comes with the package is about the static import. Static import is actually a feature which is introduced in version 5 and above of Java. This feature allow all the members as in fields and methods defined in the class as public static to be used in Java code without specifying the class in which the field is defined. So, that means if a member is public and static. So, public static members of Java of any class of Java can be used without specifying the class in which the field is defined. So, what does it mean? Let us see with the help of an example. So, here we have used import static java.lang.system.star, and we have opened one particular, we have started one particular class in which we have defined a main function, and generally we used to write system.out.println. Here we do not need to use system.out as we have already imported java.lang.system using the term static, and that is why it is known as static import. So, here in the code you can see that we have not only imported java.lang.system.start, we have imported this statically. Note the static keyword after import. So, import static java.lang.system.start, and as it has imported in a static manner or imported statically, we need not to use system.out. The only thing which we will be able to use here is out.println. Earlier we have also at every point of time we have seen system.out.println. Here I am not going to write the term system because java.lang.system subpackage has been imported statically. So, that is what you call the static import, and this static import will allow these public static members to be used without specifying the class. So, here we are not using the term system. Now, moving forward with the concept of packages, we have seen in our previous lecture that it is closely the term packages or the concept of packages is actually closely related to the or closely associated with the directory structure. But yes, here we can say this directory structure is there to use to store the classes, and the classes and the other entities belonging to the specific package are stored together in the same directory, and within the directory it can have subdirectory structure specified by the package name. So, for example, we have a base directory, within that we have a COM package, then within the COM package we have triple Z as the sub package, within the triple Z we have project 1, and then within the project 1 we have sub project 2, and within this sub project 2 we have circle dot, we have a class file which is known as circle dot class. So, here when I am talking about in packages, when we say dot, So, for example, java.util.star. So, dot in the package name corresponds to the subdirectory of the file name. So, here we have seen that in directory, when we talk about the directory structure, it will be base dir base directory /com /ZZZ /project1 /subproject2 /circle dot class. And when we take this as a package, or when we we are talking about the similar level of package, it will be named as com.zz.project1.subproject2. So, this is what we can say is the analogy, and here base directory obviously denotes the base directory of the package, and dot in the package name or in the package whole, kind of we can say the whole package path corresponds to the subdirectory of the file system. Now, the base directory could be located anywhere within the file system, and because this base directory could be located anywhere in the file system, the Java compiler and the runtime system must be informed about the location of base directory, so that they can locate the base directory, and then they can we can say they can access the classes. So, in order to access the classes which are written inside this base directory, we need to locate this base directory, and for that it is important for Java compiler and runtime system that they must be informed about the location of base directory. So, how are we going to do that? So, the answer here is the class path. It is actually similar to any other environment, similar to the environment variable path. So, I hope you understand the environment variable path, which is there to store the path of all the kind of executables we can say, or all the files which we need to access in the system. And this path variable is used by the command shell to search for the executable programs. So, here in case of Java, this term class path is also need to be set in order to make the Java compiler and the runtime system aware of that where the actually base directory is being stored, inside which the different classes are being held, or different classes are being stored. So, here we introduce ourselves to a new variable or a new environment variable, which is the class path, and we can set the class path using different ways. So, there can be kind of, let us say, two ways. One is a permanent way, another one is we can say a temporary or a non-permanent way. So, class path can be permanently set in the environment, and for those, and for this particular thing, that is to set the class path permanently within the in the operating system Windows, we need to go to control panel. Within the control panel, we need to go to the system. Within the system, there is a tab advanced, and within the advanced we need to look for environment variables, and all the environment variables are defined inside this. Within the environment variable, we will look for system variables if we want to set this class path for all the variables, or for any particular user. For example, let us say currently logged in user, we will be kind of choosing user variables. So, within the environment variable, either we will choose system variables or we will choose user variables, and then we will choose edit option if the class path is already existing and we want to add some more locations into this class path, or if this class path is not there at all, we will be choosing new, and we will be entering class path as the variable name. So, name of the variable will be class path, and within this variable or as the value of this class path, we will be entering all the required directories, all the directories which we want our class path, which we want to be inside our class path, and all the ZAR files are Java archive files, and all these directories and jar files should be separated by semicolons as different values. So, example here is we will write class path, it is the variable name, and then within the class path or as the value of class path, we have written C drive, then Java project classes, then D drive, Tomcat, lib, servlet, API, jar. These are followed by semicolons, and then we can enter many more here. Also, please notice that where we are beginning this value of the class path variable, a dot and then a semicolon is there, and then C drive, Java project, and this whole other classes are there. So, we need to include the current working directory, which is denoted by dot in the class path. So, there is a dot, then there is a semicolon, then there is one particular path which is C drive, Java project classes. After that again semicolon, D drive, Tomcat, lib, servlet, API, jar. So, that means basically here 3 locations or 3 we can say directories are entered as class path. One is the current directory, another one is the directory classes within the Java project inside the C drive, and one particular file which is servlet API.jar which is stored inside the lib subdirectory of the Tomcat directory of D drive is also kind of we can say entered as the class path. So, whatever files or whatever class files are actually stored in these locations can be directly accessed by the Java compiler or Java runtime system. So, this was one way of setting the class path, which we called as the permanent way of setting the class paths. Another way is we can use this we can do this particular thing by issuing a command on the command prompt, and that command is nothing but set class path. But using this way, the class path can be set temporarily for that particular session by issuing the following command. So, if we are going to use the command set class path, this is actually a temporary way of setting the class path. The earlier one which we have seen by going into Windows, then control panels, then system and so on and so forth, that is a permanent way of entering the class path. So, the class path which is being entered here temporarily will be valid for valid for that particular session of a CMD command shell. So, here set class path is equals to the same the dot for the present working directory, then C drive Java project classes, and that D drive within the D drive the path of servlet API jar is being included. So, this is actually we can say is the second way of setting the class path. Another way of setting the class path also comes through the command line option. So, you can also use the command line by calling the option minus class dash class paths or dash CP of the Java C, which corresponds to Java compiler and Java command. So, for example, we can say Java and dash class path, and we have given the class path, and then we can write the name of the class to be executed, which is my class 3. So, we can say Java dash class path C drive Java project classes com.abc project 1.subproject.my class 3. So, we have given as in the class path variable the value goes as C drive Java project classes, and on the next line what we have written is com.abc.project1.subproject2.my class 3 is actually a complete qualified name of this my class 3 class file, which is to be we can say executed using this Java command. So, that we can also do. So, how are these kind of packages being used that we have seen? What is the fundamental behind these packages, why they are used, that we have seen. Now, the point is how these packages are being created. So, let us try to look this creation of packages with the help of examples. As I have told you that creation of package is going to begin with the keyword package. So, here is a very kind of a small program for this demonstration. So, we have package and package underscore name. So, package underscore name so, here the package underscore name is actually the name of the package. Here it could be any variable name could be there. There could be 1, there could be 2, ONE, TWO, whatever the package name you want to give. So, package name, and then there is a class, there is a public class which is named as class 1, and within that class 1 there is a method, and that method is also named as method class 1, and this is printing hello there, it is class 1. So, here we have a package in the name of package name. Within that package we have encapsulated one class, the name of the class is class 1, and within that class 1 we have one method which is named as method class 1. Similarly, we have another package, the name of the previous package is package underscore name. Now, the name of the next package is package underscore 1, and within this package underscore 1 there is a class which is named as class 2, and there is a method which is named as method class 2, and this method class 2 is actually doing nothing but printing one statement, hello there, I am class 2. So, now we have two packages, and these two packages are having one class each, and within the class we have one method also. Now, let us use these packages or the classes defined inside these packages in another kind of third we can say file, or in the third section. So, here we have seen, we have written import package underscore name, which is the name of the first package, dot class 1. That means, we are importing this class 1 from package underscore name, then import package underscore 1 dot class 2, that means we are importing class 2 from the package named as package underscore 1, and these class 1 and class 2 both are used inside the main function, which is kind of encapsulated inside the class testing. So, we have created one object of class 2, we have also created one object of class 1, and the reference variable corresponding to them are A and B respectively. So, with A we are calling method class 2, and with B we are calling method class 1. So, when these two methods are being called, they are in actually separate files, but through the import facility of the package package techniques, we have imported class 1 from package underscore name and class 2 from package underscore 1 inside this particular file, we can say. So, here within the class testing we are using them, creating the two objects, and using those objects we are calling the we can say we are calling the respective functions also, and these functions will we can say run over, and the answer or the output here will be hello there, I am class 2, that is from A dot class 2, and then hello there, it is class 1, which is B dot method class 1. So, here we have package underscore name and package underscore 1. So, within this package underscore name, we have encapsulated or we have kept one file which is class 1 dot java. After compilation of this class 1 dot java, a class file is being created which is class 1 dot class. Then within package underscore 1, there is class 2 dot Java. After the compilation, class 2 dot class is being created, and at the outer level, so neither inside the package underscore name nor inside the package underscore 1, there is a file which is testing.java, and after compilation we have got the corresponding class file which is known as testing.class. So, in short, what we have done, we have encapsulated this particular code which is shown on the screen in one particular file which is class 2.java. Corresponding class file is also being created, class 2 dot class, and this is inside package underscore 1. Then we also have one more package which is named as package underscore name, and within this package underscore name we have class 1 dot Java, and this whole code is written inside the file class 1 dot Java. So, class 1 dot Java file is there inside package underscore name, and after compilation the corresponding class file which is class 1 dot Java is also residing inside package underscore name, and these two packages are being imported by another file which is testing.java, and we have written one main function into this, and this testing.java or this code of this file testing.java is actually importing both the packages, or we can more specifically we can say it is importing both the classes from their respective packages, and it is using them. So, here this will here is the we can say the whole structure which is being formed inside the system, package underscore name having class 1 dot class 1 dot Java, package underscore name having class 1 dot class 1 dot Java, package underscore 1 having class 2 dot class 2 dot Java, and outside these two packages, if you can see in the hierarchy or if you can see the indentation, there is testing.java, and corresponding to this testing.java there is testing.class. So, I hope now you have kind of got the situation that how these packages are going to be stored. So, basically we can say every class is a part of some package. If no package is specified, the classes in the file goes to an special unnamed package, and that unnamed package is going to be same for all the files, and all the classes and interfaces in the file will be the part of the same package. Multiple files can specify the same package name, that is also allowed. So, for example, we have package 1 inside one file, let us say file 1 dot Java. So, within that file 2 dot Java we can also have the same package 1. So, if the package name is specified, the file must be in a subdirectory. If a package is specified with the name NAME, the file must be in the subdirectory called NAME, and we can access the public classes in another package using by or we can say by completely qualifying them. So, here in this lecture we have seen how are we going to create the packages, how to use the access mechanism. Then we have also learnt about a very important environment variable which is about the class path. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed the lecture. I will see you in the next one. Till then, take care. Goodbye.